So we're all set to go. So yeah, today we're going to finish off knowledge management. We're going to look at chapter 12, which is decision making. So this is chapter 11 and chapter 12. And yeah, we didn't get too far in chapter 11, but the highlights we did touch on. And one of the things that we were looking at when we ran out of time was the IBM Watson computer. And the fact that IBM built this not to play Jeopardy, although they debuted it on the game show Jeopardy. They built it for a much more meaningful purpose, and that is to solve business problems, to work in the area of healthcare, and to spin it out into various industries.
Jeopardy by building a big database of every question that can be asked about fish, every possible fish and all the properties of fish. What would happen is I would cover like 0.001% of the data. There's no way I would be able to cover the huge breadth that's represented by the Jeopardy space. So we do not anticipate all questions and build specialized databases. Rather, our focus is to use as-is information. Encyclopedias, dictionaries, plays, books, using information as it exists and making the computer smarter in analyzing that content to compute answers and confidences. One of the ways we try to mine information, mine knowledge out of existing resources is by analyzing them. We have computer programs, algorithms that will read text as volumes of information. It won't understand it in the depth that humans might understand it, but it starts to look at it structurally, syntactically, and semantically, meaning it tries.
Yeah, so as I was explaining the other day, what they did with this machine is they basically fed volumes of text into it, scanned, actually took the time to scan text into it. And you can imagine what a huge amount of data that would be. And then they went further and broke it up with algorithms that somehow was able to pick out the subject, verb, and object from the text that was being read. And semantically, and the semantics of it is to give it meaning. So not just store the text in a database, but actually give it meaning. And that was the piece that was quite amazing. They were able to do that.
To tear it apart and understand where the subject is, where the object is, where the verb is, where the preposition is, how they all relate to one another, what part of a sentence modifies another part, and so forth. So it takes that text and produces these subject-verb-object graphs, right, with all that information in there. And then what we do is, with that information, computer algorithms start to interrelate, correlate, and compute statistics and confidences associated with that information it's extracted from that text. So it can learn things like inventors patent inventions, or officials submit resignations, or it might learn people earn degrees at school. It might learn that vessels sink, that people sink 8 balls, but only in the context of pool, right, the game of pool. So we can learn all of that, right? We can aggregate that information and use that. Here we have an example. In cell division, mitosis splits the nucleus, and cytokinesis splits this liquid cushioning the nucleus.
Yeah, so you should know that, right, Simon?
So we have to start looking at what the question's about, doing many, many searches, and generating different possibilities, like organelle, or vacuole, or cytoplasm, plasma, mitochondria, blood. These are all what we call candidate answers. Put back in the context of the question, they become hypotheses. And now what the computer's challenge to do is look at, given all the information I read, can I support one of these hypotheses as being more true than the other? So it generates what we think of as intermediate hypotheses. Is cytoplasm a liquid? Is organelle a liquid? Is vacuole a liquid? Is plasma a liquid? And it finds this sentence, for example: cytoplasm is a fluid surrounding the nucleus. And says, well, gee, is fluid a type of liquid? And of course, there are many algorithms inside Watson. Some of them look at different kinds of resources. A particular resource it looks at is known as WordNet, which is a rich thesaurus and taxonomy, a classification tree of different concepts. And it uses it to determine whether or not fluid can be considered a liquid. And of course, because it's a precise resource and looks at the actual physical knowledge, right? A liquid is a type of fluid. A fluid is not a type of liquid. So it comes back and says, I'm sorry, I don't have evidence for that. But if we looked at those learned resources, right, all that information the computer algorithms extracted from the text, what Watson learns is the way people use language, that in fact they sometimes consider fluid a liquid. And through training, Watson learns that this information that it mined from those large volumes of text is useful and predictive in the domain of jeopardy. In May 1898, Portugal celebrated the 400th anniversary of this explorer's arrival in India. Anybody? Columbus, good guess. No, Columbus thought he was arriving in India. No, actually the answer is Vasco da Gama. But one of the things I want to talk about here is the notion of evidence. Some evidence is more trustworthy or more predictive than other kinds of evidence. So if we took this question and broke it down into a bunch of different keywords, and we went out and did a search, we, for example, would consider this passage a really good hit. In May, Gary arrived in India after he celebrated his anniversary in Portugal. It's a great passage. It has all the keywords in common. It's got arrived, it's got celebrated, it's got May, anniversary, Portugal, India. And what it suggests is that Gary is the answer, that Gary is the explorer in question. And who's to say Gary's not an explorer? You could imagine the next sentence here reading, and Gary returned home to explore his attic looking for a photo album. That sentence is legitimate evidence that Gary can be classified or considered an explorer. It has Gary as the subject of the verb to explore. But is it good enough evidence to support Gary as the right answer? Could there be better evidence? Here we have the same question, but we have a different passage. On the 27th of May, 1498, Vasco da Gama landed in Caput Beach. Here we have only one keyword in common, May. Why would I even look at this? There has to be tens of millions, if not hundreds of millions of documents that contain the word may in it, right? It's used all the time, it's an ambiguous term. So even if I got to the point that I'm willing to consider this passage as possibly containing the answer, I now have to figure out how I'm going to match it. How do I relate what's discussed here with what's mentioned in the question? I need a whole ensemble of different algorithms to try to do this matching. So temporal reasoning algorithms can look at 400th anniversary in 1898 and relate it to 1498. Statistical paraphrasing algorithms can learn that, you know what, landed in and arrived in appear in similar contexts and therefore might be similar in meaning. A geographical database and some geospatial reasoning can tell me, well, gee, if I'm in Caput Beach, I'm actually in India. If I've landed in Caput Beach, perhaps I've arrived in India. This matching allows the system to hypothesize that Vasco da Gama is the answer and the explorer in question. And it should, in all its resources, get more evidence that Vasco da Gama is classified an explorer, at least more so than Gary is. So how good are humans at this task? What is a computer going to have to do? How good is it going to have to be to play human champion? So we looked at thousands of historical Jeopardy games. And what we did was we plotted the performance of the winner of those games. So every dot here represents at least one Jeopardy games. And what we looked at along the x-axis is the number of questions that the winning player got to answer. You see that the winning player answers nearly 50% of the questions in a game. And you'll also see that on the questions that they actually get to answer, they do somewhere between 85 and 95% precision. That's remarkably good. We had been working on a state-of-the-art question answering system in very good company, both universities and partners. And this is back in early 2007 that we did this. And what we discovered was that on the 5% it was most confident in, it only got 47% right. As it had to answer more and more questions, its confidence dropped and its precision dropped. So by the time it got out to answering 70 or 80% of the questions, it was down at only 15% precision, leaving a huge gap to get to the winner's cloud. And this is what, as a team of researchers, we had to face. What we came up with, which is this is the core technology underlying Watson. We call it Deep QA. It's a massively parallel, probabilistic, evidence-based architecture. So what does that mean? Massive in the sense that it's looking at many, many possibilities, starting from the original question generating all those possible searches, all those possible answers, all those possible pieces of evidence. And then as this fans out, you have hundreds of thousands of evidence-answer pairs, and now you have this big ensemble of algorithms that analyze that evidence, compute confidence scores, and ultimately have to rank all those answers and those confidence scores. And what we do here is we apply what we call learned models. We use machine learning. The system learns how to do self-assessment. It learns how to weigh those algorithms with respect to each other, and we started to refine those algorithms. But as we progressed over the years, of course, we went through lots of different growing pains. And Watson made lots of stupid mistakes along its way. So here's a few examples. The Queen's English. Give a Brit a tinkle when you get into town and you've done this. Watson, urinate. I didn't think that was too bad of an answer, but the correct one is, of course, call on the telephone. Fatherly nicknames. This Frenchman was the father of bacteriology. Watson, how tasty was my little Frenchman? Right answer, of course, Louis Pasteur. Confidence is king, so it's only going to ring in if you compute that confidence and that answer fast enough. It uses that confidence to make betting decisions and to manage risk. And one of the things you'll get to see is what we call the answer panel, which are Watson's top 5 answers. And here we have an example. In August 1812, a U.S. frigate got this nickname when British cannonballs were seen to bounce off its thick oak hull. And of course, what happens there is Watson has a good amount of confidence. This little indicator here is its threshold bar. It says, if my confidence bar is over that threshold, I want to buzz in. So it has enough confidence to buzz in. But it's wrong, actually. It's because the question's asking for the nickname, which is Old Ironsides, actually had that in second place and below confidence. So Watson will try to buzz in here, and if it won the buzz, it would have been wrong. Watson can also learn within a category, so it can develop and adjust its confidences based on what's happening within a particular Jeopardy category. As more clues get revealed, Watson starts to see what kind of thing the answer is, so it dynamically adjusts its confidence and starts to say, wait a second, you know, maybe I was wrong about what kind of thing this question's asking. So Watson learns dynamically during a game, as well as when it's analyzing and trying to read and understand and train prior to a game. Now, one of the things that's interesting to note is when we take the deep QA computation and we run it for Jeopardy, it took about, on a 2.6 gigahertz core CPU, so for example, a typical desktop computer, it took 2 hours to answer a single Jeopardy question. That would make for a very, very boring game, of course. So what we had to do is to take that computation and scale it out over thousands of cores, thousands of CPUs, if you will. And we use a high-performance computing platform, IBM computing platform, that actually allows us to run many, many, many parts of the algorithms all at once on 3,000 cores simultaneously. And that system is able to answer questions between 2 and 6 seconds. So do we answer all the questions in time? No, but the vast majority of them we can answer in competitive time, meaning we can compete with grand champions in terms of precision, in terms of confidence, and in terms of speed. So our original system gave this particular confidence curve, and it wasn't until about mid-2007 that we ended up developing that deep QA architecture and starting to populate it with lots of different algorithms. And what happened was we started to see some very early and important results. By early 2008, we actually made a huge leap by exploiting the deep QA architecture. But we saw incremental progress over about a 4-year period. You see that last line that we measured in April 2010. And what it's doing is it's slicing right through the winner's cloud. It's showing that the computer can be competitive against champion players, that on a large volume of the questions, it's doing between 80 and 90% precision. This is really, really remarkable performance and a dramatic leap from where we started. In 43 games against champion players, Watson's winning over 65%. So our next step is to first, of course, demonstrate that Watson has a competitive champion-level performance at this task. But of course, beyond that, to continue to demonstrate leadership in the broader scientific community, and of course, to take this technology and demonstrate how it can be used in business applications, including healthcare and life sciences, tech support, enterprise knowledge management, government, finance. There's lots and lots of areas where if you can get a better handle on all that rich content, you can make better decisions in your business. One of the things I like to talk about a little bit to kind of inspire the imagination here is how this kind of technology can help in medicine. If we think about when a doctor, a physician staff has to come up with a differential diagnosis, what are they really doing? Something that's very similar to what happens in Watson today and what the Deep QA technology enables. It starts with looking at lots of information, whether it be symptoms, family, patient history, medications. We have huge volumes of reference texts, journals, abstracts. We have databases and knowledge bases. How do we bring all of that together to produce a differential diagnosis? Well, guess what? A differential diagnosis is a set of hypotheses. You have to combine, look at, and analyze all the evidence in support of the different possible answers or the different possible diagnoses. Ultimately, combine all those confidences to understand which of those diagnoses is the most likely in a particular case. We think that this works not just in healthcare, but also in other areas that we mentioned, like technical support, business intelligence, market intelligence, finance, and so forth. So we're very excited about where this could go. When you see Watson playing Jeopardy, there are many natural language processing algorithms churning away on both the question and the content. But what's going on here is far beyond just natural language processing. What we've done with DQA, the technology underlying Watson, is we've built an architecture, a platform, a technology that we can advance in many, many different directions for impacting both business and society. It's one of the most advanced machines capable of understanding and dealing with natural language content that's going to have dramatic impact way beyond the game of Jeopardy.
Yeah. So it has since that video was made, it has made some real differences in a lot of areas, and hard to believe you could use that in analyzing finances, using it to analyze situations in healthcare, transportation, anywhere there's a decision that needs to be analyzed. They've been able to apply Watson in all of these areas. And so when we look back on the chapter 11, some of the things that we were looking at there, and some of the things that were even mentioned in the video, was enterprise knowledge management, to have a system that will capture knowledge, and that's just a big database. We've done that, right? But then how do you retrieve that, logically distribute it, preserve it, look at it as knowledge that may be even semi-structured, maybe just an email. How do you classify that as knowledge? What was said in the email? How can we harvest the knowledge from that? And so we need smarter systems to help us make sense of this knowledge. And especially when we look at some of it being structured, some of it being unstructured, and we're dumping it into business content management systems, organizations that are large enough to warrant having a content management system will need to classify and make sense of the knowledge that they've put into these large systems. And so when we look at doing that, we're kind of on the verge of creating our own Watson, right? We're using knowledge systems now to store knowledge, and in fact, when you look at what we're doing in education, basically what it boils down to is that the systems that we use, learning management is a content management system. It's in this classification of software. So if you look, for example, at Moodle, look at all of the courses that you take, and look at what's dumped into the Moodle system. It's very rich in content. You know, maybe some of your courses are not, you know, but to organize, for example, you know, our discussion on these two chapters, knowledge management and decision making, they go very well together because, you know, in order to support a decision, hopefully you're relying on some knowledge. And, you know, the stuff that I put under supplemental material are tools that will help us make decisions based on knowledge. And of course, a lot of it I put here in the area of Watson because it's probably the one that we can point to as being the most up to date as far as knowledge management goes right now. And some of the things that that IBM is calling their smarter planet is you know, is based on big data and analytics and how they can how can they affect change in areas such as security, urban planning, urban solutions, changing times, advanced studies, safety in numbers, in the area of energy, in the area of managing risk in business. So if you're in the insurance business, your business is managing risks and identifying risks and trying to associate a cost, you know, if that risk was to happen. And you know, just as we saw Watson being able to answer some tough questions, they're also applying those same concepts that Watson has to the area of risk and how to manage risk.
The world of BI and analytics really seems to be a never-ending race. There's so much information available, and more so every day.
The whole point of business intelligence and business analytics is to change how you perform as an organization, and change does not happen without changing people along with process and technology.
It was interesting to realize what analytics could do for Westfield. It's a matter of making the complex simple.
I can remember when I joined the company that it was not all that unusual to sit at my desk with 2 or 3 reports laid out on my desk, trying to compare and match numbers together. It was very paper intensive, and so as an employee of the company, the information was available, but it wasn't always easy to get to.
One of the challenges that we encountered, not really having a strong culture around information analytics and fact-based decision-making, was collectively we really didn't know what we didn't know. We didn't have a shortage of information. We had a shortage of useful information that we could gain insight from.
We could see that we were falling behind. So there was a very clear need of the competitive space. What had been lacking was this vision of how analytics could move our organization forward and a belief that we could do it.
We need the information internally to make good risk selection and to service our customers. Our distribution channel, our agents, need good information to be able to sell and market our products. And ultimately, to differentiate ourselves in the market, we're looking to use information to help our customers make good decisions and to manage their risk.
And you add all that up, it really requires an organization like Westfield to make sure that we're increasing our capabilities around business intelligence and analytics.
Very early on, we recognized that business intelligence isn't just about building an enterprise warehouse. It's not just about delivering reports. It's also about building an enterprise view of the data, building the structure to govern the process and the data effectively.
So we brought our expertise and some talent to bear there and combined it with IBM's technical expertise in the area of BI and some of their management and definitely their change management expertise. And that combination and partnership really worked out well.
They were able to talk not in terms of industry moves in the generic sense. They were able to look at Westfield and say, here's what we can do together to make Westfield better. We married those folks up with Westfield University to create classroom training, classroom tools, and distance learning
part of the delivery that IBM brought to the table was working with us to think through what is the best way to encourage adoption of the system, to build the skill set among our employees.
Our field people who interact with agents all the time were armed with more detailed information about the performance of the agents that they work with. And so immediately we saw a positive benefit because their conversations with their agents became more meaningful.
The most satisfying thing to me with our business intelligence program is that it's changing the organization. It's helping us make better decisions. The funny thing about it is the more data we deliver, the greater the demand is for additional information.
And being able to bring together disparate data all into one place makes us a better competitor. This project, like so many other ones, came down to the people and the capabilities of those people and their desire to make us better. And IBM did that.
Yeah, so it is a bit of an ad for IBM, no doubt about it. It's a smarter solutions and smarter planet is what they're building. But some of those areas like insurance, government, electronics, banking, oil and gas, retail, transportation systems. I mean, they have examples there for all of it, right? So, what's neat about it is that they're able to take the algorithms and the way that they can take unstructured data and turn it into information and turn that into knowledge by building Watson. That's given them the capability to look at data a whole new way. Because when you think of what they did with Watson, they took a bunch of textbooks and they just scanned them in. Then they created algorithms to put the sentences together, to parse them, to break them up, to make sense of what the sentences were saying. And for the first time ever, we had a machine that was able to learn. And you think that's not going to be used in some useful way? They didn't spend hundreds of millions of dollars to build this thing in order just to win Jeopardy, right? You got to think they did it for some other reason. And that some other reason is, yes, to spin this off into all of these industries to create products so they could sell these products to the insurance and banking industries and make money. And that's what they're doing. That's what IBM is basically bet the farm on, is that they could be the first one to create a useful set of information. And really what they're calling it is business intelligence. That's the official name. And business intelligence is being able to make smart decisions backed up by knowledge. And so that's what we see in these chapters, and that's what chapter 11 is leading us into, into an area of being able to act upon and make better decisions using the data that we have. It also talks in the later parts of the chapter, in around chapter on expert systems, an intelligent technique for capturing tacit knowledge in a very specific and limited domain of human expertise, and capture that knowledge of skilled employees in the form of a set of rules in a software system that can be used by others in the organization. So basically what they've done is they've taken and harvested the knowledge that's tacit, that's not written down, by interviewing experts in the organization and saying, if you were faced with this decision, what would you do? You've been here 25 years. Certainly you have an opinion on this. Certainly you have some pent-up knowledge that we can harvest. And then, through these interviews and asking people, they found the answer. And so that answer would be cataloged away to say that if this was to happen, here's what the expert would advise that you do. And so these systems are quite quite useful when you think of them as, being holders of many, many systems coming together. And, the area of machine learning, thinking of machines as being able to follow rules and to learn from that, to make decisions. As human beings, we take it for granted sometimes that, the decisions we make are sometimes dead easy, right? You come to a traffic light, the light is red. What decision do you make? You stop, right? We just do that automatically. We do that every day. So, going out that door, would you go left or would you go right? You'd probably go right if your car was parked somewhere to the right of that door. But what would a computer do? How would it know how to do that? And why wouldn't it turn left? Why would it turn right? So some of the things we take for granted. And, looking at a slide like this is really, looking at logic and if the car payment is less than 10% of the income, if a mortgage payment is less than 20% of the income, if D asks about years of employed, if years are greater than or equal to 4, grant a $10,000 line of credit. If years is less than 4, ask about other debt. If other debt is less than 5% of income, do F, else do I, which means set the limit to 3,000. So this person is going to come out there with either a credit limit of 10,000 or a credit limit of 3,000 based upon how much debt they have now and how long they've been working. So, if these are the rules that decisions are based on, then we could feed these into a computer system and have the person go to a website, answer a bunch of questions, and from that, the rules will determine here's how much credit that we're willing to grant you based upon risk. Based upon if you haven't been working for more than 4 years, there's a pretty good chance you might be laid off. And if you're laid off, you're not going to be able to pay the money back. So why would we lend you $10,000? No, we're not that crazy, right? No, we're gonna lend you $3,000, and that's as much risk as we're willing to put into you. So what we're starting to see in systems like Watson is that anything that's rules-based can be determined by a computer system. So why wouldn't we do this? Why wouldn't we make people smarter and free up people from having to make these mundane decisions and put them onto something else that's more exciting for them to spend their day on, and let the computer handle these mundane things, right? Other one that we have here is if income is greater than 100,000, if income is greater than 50,000, if they have real estate, if the real estate is greater than $1 million, if they have term insurance, if they have life insurance, these are all decisions about should we send an insurance salesperson out to see these people? Should we send a financial advisor out to talk to these people based on what they told us about themselves, either through our website or filling out a form of some kind? So these are the types of business decisions that are rules-based, and anything that's rules-based can certainly, end up in a machine, and it can then create these outcomes and support decisions that are made. They're certainly not going to, make the decision in all cases, but certainly, the evidence will be there to support a decision. Some of the decision software that I linked here is fairly low level, but still in all, it does give us some sense of what these systems are capable of. This one here, for example, is just an introduction to an expert system, and to see how relevant they are. And this would be a case of a car not working. So some of the, if this happened to you, then somebody would ask you a bunch of questions, right? Like, you're about to leave work but discover that your car won't start. So you contact your trusted mechanic, and they will ask you a bunch of questions, I'm sure. So, you're 100% sure that your car won't start, or let's say you're 80% sure your car won't start, and we'll start the interview. So some of the things a trusted mechanic might ask you is, what happens when you switch on your headlights? So either they light up, nothing happens, or I don't know. Let's say nothing happens. And how confident are you in that answer? Very certain, 100%. So you submit the response. So value 1 of the recommendation action is to recharge or replace the battery with 100% confidence. So if you need an explanation on that, they'll say, well, something like, the reason why we asked you to turn on your headlights was you told us your car wouldn't start. And the reason why we asked you to turn on your headlights is maybe you have a dead battery. And so if the lights don't come on, you have a dead battery. But what about the other scenario? What about perhaps the headlights did come on, right? So if we go back to that scenario, then it gets a little bit more complicated, because it's pretty easy to diagnose a dead battery if the headlights won't come on. But let's say it was a little bit more involved than that. So let's start the interview again and say that, the headlights did light up. So we submit our response. So now what happens when you turn the key or try to start the car? Let's say the car cranks normally. Oh, according to the fuel gauge, is the gas tank empty or not empty? Let's say it's not empty. The smell of gasoline is present, not present. Let's say it's not present. So we're not flooding the car, right? That could be a possibility too, because smell of gasoline usually means that the engine is flooded, right? And the recommendation action could not be determined. So the car wouldn't start. It's cranking normally. It's not flooded. According to the expert, they're not quite sure what's wrong, right? So maybe we need a further explanation on that. And something like that has stumped the expert. It's not a dead battery. You're not out of gas. Not flooded. Could be any number of things after that, right? So these type of expert systems are, what's fed into that is knowledge of a mechanic, and those are the right questions that should be asked. Here's another example here. It's called Play 20 Questions. And if you've ever played 20 Questions, the game, the way it works is you think of something, and then someone has 20 questions that they can ask you, and if they guess what you're thinking, they win, right? If they don't guess what you're thinking of, you win. So if we play it and say you can think in any language here. You can think in any genre, or Harry Potter or The Simpsons. Say, I'm thinking something about The Simpsons or something like that. But let's just do it in Canadian terms, right? And so it asks you if you're male or female, and let's put in our age is 24, and we live in Canada, and we're going to play. So, if you think of something, so let's think of something. Let's think of a whiteboard eraser. Let's see if this system can guess what we're thinking of, right? Whiteboard eraser. That's what we're thinking about. So is it classified as animal, vegetable, or mineral? Let's say it's other. It's not really a mineral, a vegetable, or an animal, so it's other, okay? So do you hold it when you use it? We'll say yes. Is it shiny? No. Do most people use this daily? Do most people use it daily? Probably not. So doubtful, right? We'll say doubtful. Can it bend without breaking? Never tried, but I'd say no, right? Can it be hunted? That's a strange question. We'll just say that's so no, it's irrelevant, right? And do you carry it in your pocket? No. Is it used for entertainment? No. Does it come in a box? I don't think it ever came in a box, did it? No. It's not like cereal, right? It doesn't come in a box. So we'll say no. Is it a common household object? No, it's a eraser brush, right? People don't have those at home. We'll say no. Does it go in your mouth? Definitely not. No. Okay. Is it made of metal? We'll say no. Can it be used more than once? Yes. Is it made of wood? No. It's made of plastic and wool or something, I guess. I don't know what it is. Would you find it in an office? Sometimes, right? Because people might have whiteboards in their office. Sometimes, we'll say. Do you use it in your home? No. Well, we'll give it a chance. We'll say rarely. I'm guessing it's a blackboard eraser. Now, how in the heck did they figure that out, right? Question 17, they got the blackboard eraser. Now, how did they get that? The last question was, do you use it in the home? And I said, probably not, right? Yeah, so that's pretty smart, isn't it? Question 17, they won. So I'll have to say right. You're right. You're thinking of a blackboard eraser. Close enough, right? Whiteboard eraser, blackboard eraser, I'll give them that. I'm not going to distinguish between dry erase and chalkboard. They got it, right? So what this system has been doing for the last, I don't know, 10 or 12 years, it's been out there as a website, right? It's called play20questions.com or 20q.net is what it's called, www.20q.net. And people have been playing this game. And you talk about learning. This thing has learned from day one what weird things are. And when I play this with different classes, sometimes it's not as obvious. It's just a dry erase marker. Sometimes we make it a really weird thing. And 9 times out of 10, this thing guesses what we're thinking. Like it's that smart. And you might think it's way off base. Like it's asking me weird questions like, do you put it in your pocket? And, we think we have it stumped when it starts asking weird questions like that. But actually, it's eliminating all of the things that it can't be, right? By saying no to that, well, it can't be. All of those other things. Like, do you put it in your mouth? That eliminates a whole lot of things, right? So it narrows it down and figures out what it is we're thinking about, and it won. So yeah, it's just sitting out there, and it's it's a demo of an expert system because it's learning all the time by people playing. So just from us playing the game, it's learned, and it'll probably get the answer in less than 17 questions next time, right? It'll just keep getting better. So it's it's those types of systems that we're talking about when we talk about expert systems. Like it could be in a medical domain where you know, you go to a website and they ask you, what's wrong? And you say, well, I can't breathe through my nose. You know, next question might be, are your eyes watering? Next question might be, you know, are your ears sore? So it's figuring out, you know, do you have a breathing problem? And if so, is it the common cold, or is it something a little bit more serious? You know, by asking you questions, you know, and how does it know to ask you those questions? Well, perhaps a medical doctor put the questions into the software, and it's asking you the right questions at the right time. So that's really, really neat when we see that. Just to take it one step further, then, just to see what, you know, companies like Google and are doing in this area of expert systems, and how we can move this into business.
Articulated Naturality Web is a complete renaissance in the way we approach technology. Convergence has seen us through to the mobile device, and what we now want to embrace is what's known as computer vision. The ability to see the world for what it is as a scene, and to see the elements within, the floor, the walls, the objects in it. And once you know that, you can relay information very cleverly. A&W allows us to do amazing things. It's going to remove the barriers that currently exist in terms of traditional AR is very flat. A&W is going to bring a three-dimensional element, a virtual universe of sorts that we can take advantage of anywhere we are, anytime we want. For instance, the weather. Holding a device up to the sky and seeing the iterations of weather. Perhaps a cloudy morning, and then throughout the afternoon behind that you might see something like a cloud or some wind or some other relevant information. In an urban setting, A&W will allow you to reveal things you wouldn't normally know from the outside environment. Say you're walking down the high street and you see a museum. You can identify objects in the museum. What the main difference is, where AR is very flat, AN actually observes the scene and identifies the elements within. It then attaches the information very intelligently and accordingly. There are massive opportunities for the hotel industry. You can not only browse for room availability, but also take a look inside the room before making a booking. Take, let's say, commercial real estate, for instance. We need an office. We walk in, we have 16 employees. We put that into an articulated naturality environment, and you can virtually see how the desk would be set up, perhaps configure them, perhaps change the color, change the type of ergonomic posture, change the seats, whatever you want, and you can see the costs related to any changes that you would make. What A&W will do is break that barrier we have with the conventional desktop, the conventional laptop. We want the convenience of having this information wherever we are, whenever we want it. Current technology only provides us with 20, maybe 30% of the actual digital experience. With A&W, we get 100% of the experience. By embracing this new virtual world, what we do is we open a door to a virtual universe where our mind is the only boundary.
Yeah, so that's pretty futuristic, isn't it? But you can see that coming, right? You can see that with more and more people having smartphones, we got to make them more useful, right? And it says current technology is only 20 to 30% of the experience that it captures and is able to tell us about. And Google's working on Google Glass, right? And Google goggles and things like that. And that's what they're trying to make it.
Hi, I'm Shailesh, and I'm a product manager at Google. I want to tell you about an interesting experiment we're running with Google Goggles. Goggles is a product that allows users to do a visual search. It works like this. A user takes a photo of an object, and using Google's image recognition technology, Google returns relevant search results. Every day, people are googling all sorts of things, including ads. This caught our attention. What if marketers could connect a consumer's offline experience to an immersive digital experience on their mobile device? To learn more about how this might work, we've engaged in this experiment with 5 pioneering advertisers: T-Mobile, Diageo, Buick, Disney, and Delta.
Google Goggles is a great way for us to combine a lot of elements that we know our consumers want. They're on the go, they want information, they may want recipes, they may want offers, and we want to be able to provide that for them wherever they may need it.
Here's an example of a goggles-enabled print ad for Buick. The consumer launches goggles on their phone, photographs the ads, and Goggles takes the consumer to the relevant content on Buick's mobile site.
Our overall objectives for this are pretty simple. We want to create a more rich experience for consumers. So when they come to a print ad, it's enabled with Google Goggles. It gives them the opportunity to then get a deeper, richer experience with the brand.
One of the biggest benefits of the Google Goggles advertising campaign is that the consumer can choose when they want to go and have this deep experience.
Goggles gives us a great opportunity to test at scale in a really effective way.
We know that mobile is the one common tool that everybody has with them, whether it's in their hand, on their nightstand, or in their back pocket.
More and more, users are conducting visual searches to explore the world around them. We're looking forward to learning about how we might deliver the most meaningful and relevant visual search results.
Yeah. So that's where they're, that's what they're looking into now, right? Augmented reality. And augmented by what? Augmented by a computer or some type of device that you have with you, like a mobile phone. And so you're augmenting reality. You're adding to. That's what augmented is, right? You're adding to reality. You're making reality and the things around you more richer. They're giving you more information. As if we don't have enough information now, right? You pointed at a building. It might be a hotel and tells you right away how many rooms are free. And oh, by the way, do you want to see what a room looks like without even having gone into the building? So that's pretty rich, right? That's pretty augmented. You're not just looking at a reality. You're not just looking at a building. You're looking at something in addition to the building. You're augmenting that with information. So, we can see where this is going, right? You can kind of put it all together and say, we're probably going in that direction for sure. And when we started the course, we talked about 1% of the technology we have now, and we can go back to this and see it. The technology we have now, we're pretty blessed, right? We think we have the latest and the greatest. Laptops that are paper thin, cell phones that are paper thin and light, and we can look up an answer in 5 seconds. But only 1% of the technology we have now will be. That's what the technology we have now will be worth in the year 2050. In the year 2050 is only about 35 years away. So in 35 years' time, everything we have now is only going to be worth 1%. Where does the other 99% come from? Right? Where does that come from? Well, it comes from things like Watson, things like Google Glass, things like who knows what's out there, right? So I don't know, like in another 35 years, I can see the way knowledge is going, getting back to the subject of knowledge management, I can see a time where a person would probably go, learn the basics, maybe get through, grade 7 or 8, maybe finish grade 9, get the mathematical basics, introduction to science, and then that'll be it. Like post-secondary education will be moot. There'll be no need for it. Everything that is known, right? The knowledge is there, and so we will use that and we will rely on that knowledge base in order to help us make decisions. But we know we will have a basic understanding of the principles of science and math and history and geography and things like that. But then after that, the knowledge management systems will kick in. That's what I'm thinking anyway. So, I'm not giving education a long term. In other words, I think it's a short term thing. I may be wrong, but hey, that's just the flyer that I'm taking on it, because I can see these systems getting smarter, really smarter. So who knows, right? And if you tell someone that today, that education systems are going away and there's going to be no such thing as post-secondary education in another 30 years, they might not agree with you. But who knows, right? So when we look at chapter 12 on decision making, it really goes hand in hand with chapter 11, and it's really talking about analytics, and the whole idea of analytics can be brought to life in this movie. This movie was made a couple of years ago. It's called Moneyball, and what it opened up was, it opened up a whole new world most people didn't even know existed. That you could actually use data to form that data into information, and then to form it into knowledge, and enable a baseball team to make a decision as to what pitcher they're going to start versus what team they're playing, versus how many strikeouts that pitcher had last time we played the team, and who's playing and what's their batting average, and so on and so forth. And you put a massive amount of those statistics together, and what was happening in the movie was that it was making decisions that should have been made by managers and coaches, were now being made by software. And so, you might look at that and say, well, geez, that's science fiction, right? That's a movie. That's never going to happen. And yeah, it is, right? It's gotten to that point where even out of the professional leagues, they're using it. In the semi-professional and amateur leagues, they're using systems like we saw in that movie Moneyball to help them make better decisions. And the Quebec Major Junior League is one of those teams that I've been talking to recently. I think I posted it here on the page one of those weeks back. I think it might have been around the end of September or something like that. I posted it. Yeah, right here. St. John Sea Dogs Analytics. They made an announcement, a press release, that like they weren't trying to hide it, right? You think if they were doing it, they might try to hide it so that the other team wouldn't know they're analyzing them? No, they made a press release, an analytical program, and they've got some of the best hockey minds in this part of the world working for them, and they list down here who they are, and they're going to use this in their future games, and hopefully it's going to improve their wins, right? So, yeah, that's what they're doing. And believe it or not, they're teaching this. Where's the guy that, yeah, this is the guy here, Stephen Cocker, player development analyst, working towards a degree in sport and leisure management at Haaga-Helia University in Finland, and he's writing his thesis on the progression of analytics in hockey. So he went to this specialized university in Finland to learn how to do sports analytics. And you can get a degree in that now. So, yeah, it's more than just a movie, right? So it's that level of decision making that, that's real. It's not science fiction. And you'd have to figure if they're using it in sports, they've got to be using it in business, right? To make smarter decisions. Of course they are. That's why it's in our book, right? They wouldn't mention it if it isn't. The whole area of analytics is one of the hottest areas going right now. And you know, it helps us, especially in these times where we have to make unstructured decisions. Unstructured decisions are usually reserved for the top of the pyramid, right? In business, up here at the top, you have your CEOs and CFOs and your chief information officers and your chief marketing officers, and sometimes they're called chiefs and sometimes they're called vice presidents. Whatever they're called, these are the people at the top that usually have to make these one-ofs. Never saw it before, never heard of it. Now it's your problem. What are you going to do about it, right? Novel, non-routine decisions requiring judgment and insight. Examples would be to approve capital budgets, decide on corporate objectives. It's not something we do every day, right? As opposed to structured decisions, which are routine. And those types of decisions would be made maybe at these lower levels, but the unstructured stuff is up here, right? Novel, maybe one every 5 years. You'd see something like that. So in order to support people making those decisions, what we have to do is we have to employ smarter systems. We saw in that video about that insurance company. We heard the lady telling us, right? And the guy telling us that they didn't know what they didn't know. That's a sad place to be, where you don't know what you don't know. It's bad enough that you don't know what you should know. But if you don't know what you don't know, you're lost, right? You're just sculpturing in the fog. You're reaching for sky hooks that aren't there, right? So, you know, it really comes down to the shortage of useful information. They had all kinds of information, but how do you make that useful? You know, how do you structure that in such a way that's going to help you make a decision? And that is the problem, right? And that's why we see, you know, in our case, we do projects in this course, and as I was telling you, the projects get, I wouldn't say, because some students ask me, you know, are the projects going to get more difficult? And I said, not really. They're just going to be different, right? They should be different. They should be taking us up the food chain, right? So that the projects give us more of a challenge, and they're not so straightforward. And so, you know, in projects 5 and 6, we are looking at projects that really aren't more difficult, but what they're going to do is provide us with knowledge that will help us make a decision. So if we look at project 5, for example, the one on HR, the number of people that are going to retire and when they're going to retire, that would be useful information to a HR person if they had to do some planning over the next 3 to 5 years. And looking at the first one on commissions and bonuses, right? Who's your best salespeople? Well, I don't know. Like, how do you find that out? I don't know, right? You don't know what you don't know, right? That's not a good place to be. If you had a spreadsheet, you had some way of analyzing how well they were selling, and you could classify them as an A, B, or C, or 1, 2, or 3, then that would be useful, right? Sure it would. So, you know, chapter 12 is really, you know, explanatory in and of itself, because when you read through it, you say, yeah, you know, software can figure into this and help people make decisions at all levels of the organization, not just at the very top level. Yeah. Okay, so I did want to talk about case study number 2. As we move along in the calendar, not this week, not next week, but the following week. It's going to be the week of 16th to the 22nd. And what I created today was this magnificent beast here. It's a way for you to register your app, so that if you have your app finished, you can register into the store. This is what this is. This is the store, and I'll probably pretty it up and make it a little bit more presentable as I have more time. But basically, everything you need right now is here. So you can register your store. You can put it into a category. Let's say your category is music. Your app name is called More Music, Please, or something like that. More music. Your tagline is, you know, we have the best music, or whatever it is. And your URL, you would put that in there, right? What your URL is. And then your last name, first name, and your email address. And then you would submit it. So, as you submit it, thanks for your response. And it's now cataloged, right? So maybe the next thing you'd want to do with your app is create a buy button. And in the instructions, it did say that I was going to give you a magic URL so that you could link that to your buy button in your application. And this is it here. And it tells you that you should copy out that URL and replace the app name you entered when you registered your app. If you've forgotten what you wrote in the look in the store, your app name contains spaces. Then you have to replace the space with a %20, so on and so forth. And so just giving you an example here, if your app was My Great Trips, then you can see they use this URL, and at the end of it they put my %20 great %20 trips. And that's just a way of connecting, so that you don't have blanks in the web address. And that's what you'll use. So to give us to give us a reference as to what this looks like when it's all done, here's another school of business, and they've got apps registered on their website. We will have this when we have some people registered. Let's pick one called Numbers Matter. Let's see if we can bring that one up. So here's an app that was developed. It's called Numbers Matter. It's applying to college is not the only tedious process, but stressful one. It takes weeks to get your application together, contact your high school, send in the proper information, so on and so forth. So they created an app for this, right? And this was their idea, and how their app would work, and basically what it would look like on the various screens, and so on and so forth. And so when we click on this buy button here, what it's going to do, and what we see down here is we see exactly where it's going to take us, right? So that big long URL that starts over here and ends over here was copied in and placed behind that link, so that when a person clicks on that, it will take us back to the and connect it back to the store, right? So the person would say, yeah, that's the app I'm buying. Here's my email address. Here's my first name, last name, and submit. And that's, and that would be registered as a buy. So each individual page then that you create will link back to the store. And if the person wants to go back to the store, they just click on store, take us back to the main page, right? And there's your app, and then, you know, your About Us is there, your blog is there, you know, what your app looks like is on the main page. There it is. So all of these apps then are hooked back to the store, and every time someone buys one of these apps, it's counted in here, right? So this is the count that is happening. 30 people have bought that app, 28 people have bought that one, and so on. See, this person put the right information in the wrong place, right? They put their URL in where they're supposed to put the name of their app. Happens, right? So nothing that couldn't be cleaned up for sure. So yeah, so right now in our store, I have the register your app. I have that form. I have how to create your buy link. I don't have the sales data turned on yet, but once we have some sales data to talk about, I will turn that on. And of course, the main store, as people register, you'll start to see these apps listed here in the store under the categories that are listed here. So that's what theirs looks like, and ours will look similar to that. So right now it's kind of got the UPEI theme colors going there, and I only have two things. I don't have the store turned on, but it's there. I just have to turn it on, and it shows a spreadsheet with all the apps that are registered. But first, you have to register. You know, and every time someone registers, I'll get a new line in the spreadsheet. So yeah, we'll talk more about that next week, and you know, you can start thinking about this app that you're going to create and what it might look like and all of that wonderful stuff. And just a reminder then that next week is a short week. November 10th is Student Development Day. So happy developing. And November 11th is our Remembrance Day. So those 2 days are non-class days. So we'll see you back here next Thursday.